Him that the last time he sent the money, it was not enough to buy all the provisions.
Oh, sorry, I forgot to tell him.
Are you guys talking about money transfer to buy provisions?
Yes.
But don't you know about Baluwo?
Baluwo? What is Baluwo?
Baluwo is a service that your son can use to send provisions directly to you guys from the shop. And you don't have to worry about the exchange rate.
Tell me how Baluwo works.
It's very simple.
Just log on to baluwo.com and shop, or download the app on your phone. You can shop on the website or using the app to buy online basic products for your family and friends. With Baluwo, you decide what your money is spent on. Your money, your choice. Buy online products for your family and friends in the Gambia, Senegal, Nigeria or Mali. Baluwo, better than sending money.
Hi, my name is Buba Gajigo and you're watching Kerr Fatou. This is your educational program, and now we're gonna bring you lessons from senior school. If you have your kid attending senior school, get them prepared, and I hope you enjoy these lessons.
Are you thinking of owning your dream homes? EJ Investment is here for you. Secure our quality bungalows with 2, 3 or 4 bedrooms, or our story buildings 3 or 4 to 5 bedrooms at very affordable prices with flexible payment plans at our Sanyang Seaview Estate, where you can enjoy the cool breeze with modern infrastructure such as tar roads, covered drainage system, modern electrification with street lights, gated entrance with security posts, and social amenities such as gas station, shopping mall, medical clinic, park, schools, children daycare, and a lot more. Our dedicated team of professionals will keep the estate clean at all times, provide security and patrol team within the estate premises, install latest technologies such as CCTV, Wi-Fi, home network installation, solar panel, and power backup system. Also, check out for our additional home facilities and interior design service such as premium tiling, wall plaster, home landscape, fingerprint home lock, and a lot more. Visit our office at Senegambia Kodoli Highway and get a free site visit tour, or contact us on 4464838. WhatsApp us on 3259220, or you can visit our Facebook page or Instagram on EJ Investments. EJ Investments, we are first in properties.
Hello viewers, these are key messages from the Ministry of Basic and Secondary Education on the coronavirus. Dear parents, keep children at home at all times. Avoid sending children to shops and markets. Do not engage children in petty trading on the streets and garages. Allow children to play within the confines of the home. Limit visitors into your homes. Adhere to COVID-19 health precautions and guidelines. Schools are closed, but learning continues. Dear teachers, you are encouraged to desist from all forms of group activities involving students. All school premises should remain closed and not to be used for any other purpose. Thank you.
Hello, my name is Mr. Yusuf Ajalo. I welcome you to my chemistry class. And in our today's lesson, we're going to look at alkanols. Alkanols are organic compounds that are of utmost importance. So, what are alkanols? An alkanol is an organic compound with an OH group, which we call hydroxide group. It can also be represented as ROH, where R stands for an alkyl group and OH hydroxyl functional group. Okay? So R here is the carbon chain. And then if you should look at this, the simplest alkene, which is made up of one carbon, and it is called methane. If you want to make this as an R group, of course, we're going to remove a hydrogen. And when we remove a hydrogen, we'll have CH3, and this becomes our R group. So we can attach the OH functional group to make it an alcohol. So every alcohol must have an R group, which is always made up of an alkyl group. And then the alkyl group can be made up of one carbon or more than one carbon. So the simplest alcohol we can have will be made up of one carbon, which is called metanol. Okay? So going further, we're going to look at the nomenclature of alcohols. How do we name alcohols? We're going to look at the nomenclature of alcohols. In naming continuous chain and substituted alcohols, drop the E ending of the parent alkane and name and add the ending OL. The parent alkane is the longest continuous chain of hydrocarbons that include the carbon attached to the hydroxyl functional group. So let's take an example of what we've said. If you have this as our compound, to name this compound, we have to identify the longest hydrocarbon chain. And then we identify what? The position of the functional group. And the functional group here is the hydroxy group. And looking at this compound, we have 1, 2, 3, 4, 5 carbons. Okay? So the parent name of this compound is pent, which is the prefix for 5. And then the functional group here is the OH, and then the OH is on carbon number 2. So on carbon number 2, we have the OL, suffix, that is the functional group alcohol. And to name this compound, we'll name this as 2, which is the position of the alcohol, and pent, which is the prefix for 5, and then AN. If I told this was an alkane with 5 carbons is called pentene. Sorry, E. So since this is an alcohol, the OH substitutes what? A hydrogen. So therefore, we're going to drop the E from the corresponding alkene and then add the suffix OL. So therefore, we write this compound, the name of this compound as pentanol. Okay. In numbering the longest continuous chain, the position of the hydroxy group is given the lowest possible number. That is, it takes precedence over alkyl groups and halogen substituents. For example, if we have that compound as our example, and we want to give it a name, how do we name this? Like one of the rules mentioned that the functional groups should be given precedence. That means we should give the functional group the lowest numbering. So looking at this compound, if we should start counting from our left, this is going to be carbon number 1, 2, 3, 4, 5, and 6. That means the longest hydrocarbon chain is made up of 6 carbons. Okay. And then the prefix for 6 is hex. We write that first. Then on carbon number 4, we have an OH group on carbon number 4. And if you should count from our right, that's going to be our carbon number 1, 2, 3, 4, 5, 6. Okay. Counting from our right, our functional group is on carbon number 3. If you should consider the substituent here, which is a methyl group, the methyl group, if you should count from our left, the methyl group is going to fall on carbon number 2. And if you should count from our right, the methyl group falls on carbon number 5. And here, the lowest numbering for the methyl group is 2, and then the lowest numbering for the alcohol is 3. But since alcohol takes precedence, we're going to count from our right, not from our left. Because from the left-hand side, the alcohol is going to be on carbon number 4, but from the right-hand side, the alcohol is going to be on carbon number 3. So therefore, this compound will be named as 5-methyl. That is, the methyl group is on carbon number 5, and then 3, which is the position of the functional group, hex, which is the prefix for 6 carbons, and then we add the OL suffix. Okay. So we name this as 5-methyl 3-hexanol, but not 2-methyl 4-hexanol. Okay. This is correct, but this one is wrong. Why? Because this gives the lowest number into the functional group, and that one gives the highest number into the functional group. But instead it gives what? Lowest number into the alkyl group. And then functional groups takes precedence over alkyl groups. So let's take one or two examples and we try to name them. Our example 1 has a compound like this. Okay. To name this compound, we're going to follow the rules. The first rule states that we need to identify the longest hydrocarbon chain. And then the functional group should be part of this longest hydrocarbon chain. And that is, if you should count from left to right straight, the OH, which is the functional group, is not going to be part of the longest hydrocarbon chain. So we cannot take it like that. But let's try to count it from here, down here, and see 1, 2, 3, 4. So if you should count from down, moving towards what? Our right, up, we'll have 4 carbons. But if you should move towards the left, we'll have 4, 5. So going towards the left, we'll have 5 carbons, and going towards the right, we'll have 4 carbons. And then 4 and 5, 5 is greater than 4. So the longest hydrocarbon chain will be in this direction. That is 5 carbons. So the next thing you do is, after identifying the longest hydrocarbon chain, you give the lowest number into the functional group. So obviously, if you should start counting from down there, the functional group is on carbon number 1. And if you should start counting from there, from the left, the functional group is going to fall on carbon number 5. And 1 is lower than 5. So therefore, we'll count from down there. So that means our functional group is on carbon number 1. Our functional group is on carbon number 1. So 1, and then the longest chain is 5, pentan. So pent is the prefix, but in naming alcohol is the E from the alkane, corresponding alkane that we drop and add OL. And this group here is not part of the longest hydrocarbon chain. So this group is referred to as a substituent. And then we need to mention the position of this substituent. And the position of this substituent here is on carbon number 3. So we'll have 3. And the substituent is made of only 1 carbon. The prefix for 1 is met. Then the suffix YL is added. So we can put this together to name this compound. So to name this compound, we'll name the substituent first, which is 3-methyl. Then comes the position of the functional group, which is on carbon number 1. And then the number of carbons, which is 5, pentan, and then the suffix OL. So this compound is named as 3-methyl 1-pentanol. We can also name it in another way around. That is, we can write 3-methyl pentan 1-ol. Okay. So either way is accepted. Okay, let's look at the second example, which is so that's our second example. Let's try to give a name to this compound. So the first thing we do is we identify the longest hydrocarbon chain. Then we give the lowest number into the functional group. Since we say functional groups takes precedence over alkyl groups and then halogens. So here we're going to follow the same thing. We will count from left and we will count from right. So counting from our right, this is going to be carbon number 1, 2, 3, 4, 5, 6, 7. And counting from our left, that's going to be 1, 2, 3, 4, 5, 6, 7. So either way gives us 7 carbons. So that means the longest hydrocarbon chain is made up of 7 carbons. So we write the prefix hept for 7. Then we have substituents which are not part of the longest hydrocarbon chain. One is organic and the other one is inorganic. Okay? But before we give numbers to the substituents, we first need to give number to our functional group. And what is the functional group here? Is the OH. So the lowest numbering for the functional group, if you should count from our right, is carbon 3. If you should count from our left, is on carbon number 5. So 3 is lower than 5. So the position for the functional group is 5. Then the substituents, the first substituent is chlorine, and it is found on carbon number 5. If you should count from our right. So this is going to be 5. Sorry. This was 3. 5 chloro. And the alkyl functional substituent rather, the alkyl substituent is on carbon number 6. So you'll have 6 methyl. Now we have identified the longest hydrocarbon chain, the position of the functional group, and then the position of each of the substituents. So what we do is we put this together to give a name to our compound. First we start by naming what? The alkyl group, sorry, the substituents. So we have 2 different types of substituents here. One is organic, that's this one, methyl, and then the other one is inorganic, which is chloro. But in naming, we name the inorganic first, so therefore we'll go by naming the chlorine first. So this is going to be 5 chloro. And then the alkyl group, which is methyl, is on carbon number 6. 6 methyl. And then the position of the functional group is 3. And then the longest hydrocarbon chain is made up of 7 carbons, which is hept. And then the suffix for alcohols or alkanols is OL. So this compound is named as 5-chloro, 6-methyl, 3-heptanol. Now we're going to look at the classification of alkanols. How do we classify alkanols? Alcohols can be classified as primary, secondary, and tertiary. So this is how we classify alcohols. We can classify them as primary, secondary, or tertiary according to the number of R groups attached to the carbon that bears the functional group. We've looked at an R group before. We said an R group is an alkyl group, which can be made up of 1 or more than 1 carbons. So depending on how many R groups are attached to the carbon that bears the functional group, that is the alcohol, OH, or the hydroxide group, we can classify alcohols as primary, secondary, or tertiary. So let's start with primary alcohols. How do we classify primary alcohols, or how do we identify primary alcohols? So this class of alcohols have only one R group attached to the carbon with the OH. That is, we'll have only one R group attached to the carbon that bears the functional group. So if you have a type of alcohol that looks like that, we refer to it as a primary alcohol. Let's take an example. So this is an example of a primary alcohol. Why? Because this carbon here is the carbon to which the OH is bonded. Let me show that bonds. That's the structural formula of this molecule. So looking at this molecule, you can see there is only one carbon bonded to the carbon that bears the functional group. That is the OH. So this group here is your R group. So since there is only one R group attached to the carbon that has this OH, we refer to this as a primary alcohol. So this is ethanol, and ethanol is an example of a primary alcohol. Next, we look at secondary alcohols. How do we identify secondary alcohols? This class of alcohols have two R groups attached to the carbon with the OH. So we'll have a general formula of R2 OH. Okay. So this, we can have an example. So if you look at this example here, we have this methyl group as R1, another methyl group as R2, all attached to this carbon that bears the hydroxy functional group. Okay. I can write the structure or draw the structure. So that's this structure here, and we can see that this is the carbon to which the OH is bonded to, and we have this other carbon here with the 3 hydrogens bonded to the carbon that bears the functional group, another carbon with 3 hydrogens bonded to the carbon that bears the functional group. So we have 2 R groups. Since we have 2 R groups, then we refer to this compound as a secondary alcohol. Okay. And finally, we have what we call tertiary alcohols. How do we identify tertiary alcohols? This class of alcohols have 3 R groups attached to the carbon with the OH. That is, we'll have something like this, 3, then CH. OH. Okay. Let's take an example. We should have a compound like this. This compound has 3 R groups. This can be your R1. That's an alkyl group. Another alkyl group, R prime, double prime. This could be R prime, R double prime, and then R triple prime. So this is the carbon to which the OH, which is the functional group, is bonded to. So looking at this carbon, it has 3 other carbons bonded to it, or 3 other R groups, that is alkyl groups bonded to it. So therefore, this molecule will be referred to as a tertiary alcohol. Okay. So this is how we can, or how we classify alcohols based on the R groups attached to the carbon that bears the functional group. But another thing we can use to classify alcohols will be based on the number of hydrogen atoms. Like when we look at the first example, that is primary alcohols, we'll observe that the carbon that bears the functional group has 2 hydrogens attached to it. Okay? So this has 2 hydrogens bonded to the carbon that bears the functional group. So this carbon here is the carbon to which the functional group is attached to. So it has an alkyl group, which we've used to classify them. Another method that we can use to classify primary alcohol is the number of hydrogen atoms attached to the carbon. Okay? So if you have 2 hydrogen atoms attached to the carbon, then we refer to it as what? A primary alcohol. Why? Because looking at this, the OH substitutes a hydrogen from the alkyl group, that is CH3, CH3. This is supposed to be the compound, that is an alkene. This is ethane. So the OH substitutes a hydrogen. So one hydrogen is being substituted from here. So that's why we end up having 2 hydrogens. So if a hydrogen is substituted from an alkene by an OH, then we can classify that compound as a primary alcohol. Okay? So secondary alcohols can also be classified using the same method. Like, for example, this was one of the examples we look at. Okay. This carbon here has only 1 hydrogen attached to it. Okay. So 2 of the hydrogens from the alkene are being replaced. Okay. One is replaced by the OH, another one by an R group. So looking at this structure here, we can classify this as a secondary alcohol, okay, based on the number of hydrogen atoms bonded to the carbon that has the functional group. Okay. Another way to classify tertiary alcohols will be the number of hydrogen atoms attached to the carbon that bears the functional group. So in a tertiary alcohol, there is no hydrogen on the carbon that bears the functional group. All the hydrogens are being replaced. As you can see, there is no hydrogen attached to the carbon that bears the functional group. So therefore, this is referred to as a tertiary alcohol. Okay? So basically, these are ways you can use in classifying alcohols. We can classify them as primary, secondary, and tertiary based on the number of R groups attached or the number of hydrogens attached to the carbon that bears the functional group. Okay. So let's take these examples. Let's try to solve these questions. We have the following compounds. The first one is and then the second one is and then the third compound is so we have these 3 different compounds. We have to state to which class each of these alkanols belongs to. So let's try to classify the first one. We're going to look at how many R groups are attached to the carbon that bears the functional group. So this is the carbon to which the functional group is attached to. But we have 3 other metal groups, and all these metal groups in parentheses are attached to the carbon that bears the functional group. So each of the metal groups is an R group. So since we have 3 R groups, therefore this is going to be referred to as a tertiary alcohol. Okay. We can look at that. We can break things down. Then OH. So these were the 3 metal groups that were in parentheses. So you have 1, 2, 3. And excuse me. Each of these metal groups is referred as an R group because it's an alkyl group. So the first one is classified as tertiary alcohol. Looking at the second example, the metal group in parentheses is bonded to the preceding carbon, not the carbon that comes after it. So therefore, this methyl is a substituent on carbon number 2, if you should start counting from the alcohol end. That is the functional group OH. So therefore, this carbon, the methyl group is not bonded to the carbon that bears the functional group. This is the only carbon that is bonded to the carbon that bears the functional group. So therefore, this is called a primary alcohol. Why? Because we have only one R group attached to it. So the whole of this is just one R group attached to the carbon that bears the functional group, that is the OH. So this is referred to as a primary alcohol. And then the final example we have here is, we have 1, 2, 3 carbons. Because this carbon here has this CH3 attached to it. So the methyl group is attached to the preceding carbon. So as the functional group, which is OH. They are all attached to the same carbon. Let me break that down for you. That's going to look like this, CH3. So this is how this structure looks like. So looking at this, you have one R group and then another R group. So we have 2 R groups attached to the carbon that bears the functional group. That is the OH functional group. So therefore, this one will be referred to as a secondary alcohol. And also, if you should look at the number of hydrogens attached, the first one has no hydrogen. So therefore, it is what? A tertiary alcohol. The second one has 2 hydrogens bonded to the carbon that bears the functional group. So it is called a primary alcohol. If you look at the third example here, we have only 1 hydrogen attached to the carbon that bears the functional group. So we refer to it as a secondary alcohol. Okay, next we're going to look at the physical properties of alkanols. Physical properties. Alkanols have high boiling points because they are capable of intermolecular hydrogen bonding within themselves. Since they have the hydroxy functional group, which can hydrogen bond, so they will hydrogen bond within themselves, and this gives them high melting and boiling points. The lower members are very soluble in water because of the presence of what? The OH in them. Like carbon from C1 to C4 are very soluble in water. Okay? They can hydrogen bond with water. So that's why they are very soluble in water. How do they dissolve in water? It's through hydrogen bonding, because water also has the OH. So there will be hydrogen bonding between the two molecules, which enables them to dissolve in water. Okay. But as the number of carbons increases, their solubility in water decreases. But instead, they become more soluble in organic solvents because of it. So alcohols has this property. They can dissolve in water. They can also dissolve in organic solvents. Why? Because they have what? The R group, which is non-polar, which can dissolve in non-polar solvents, and then the hydroxyl group, which is polar and can dissolve in polar solvents like water. Then we talk about, or then we look at the chemical properties of alkanols. Let's look at the chemical properties. One of the chemical properties of alkanols is reaction with alkali metals. That is group 1 metals. Example, if you have a propanol, for example, reacting with sodium, this is propanol, or 1 propanol, because the functional group is on carbon number 1. When this reacts with sodium, which is an alkali metal, the product will be an ether salt. Plus the hydrogen gas will be released. Okay. So this reaction will produce ether salt, and then hydrogen gas will be given off. So they can react with alkali metals. Another reaction of alcohols we look at is reaction with alkanoic acids, and this process is called esterification. Okay. The process of preparing esters, or the process of making esters, we call it esterification. That is the reaction between alcohols and alkanoic acids. For example, if you have a propanol reacting with metanoic acid in the presence of acid and heat, this reaction will produce an ester, okay, which is another functional group, and the ester will look like this. So we'll have this as our ester, and then water will be given out, or water will also be produced. So the ester is named as propyl metanoate. So the propyl is the alkyl group, which is made up of 3 carbons, and the metanoate is the functional group, ester functional group, that is the COO. COO is the ester functional group. So if you want to prepare an ester, you can react an acid with an alcohol. Another chemical properties of alcohols is reaction with concentrated sulfuric acid. And we understand that sulfuric acid is a dehydrating agent, okay? Meaning it is going to remove a water molecule from the alcohol. So in the process, we'll have another chemical compound. Let's take an example. We can stick to the same compound, that is propanol. When propanol reacts with concentrated sulfuric acid, this will remove OH from the carbon that bears the functional group, and then a hydrogen from the adjacent carbon, and this is the adjacent carbon here. So as a result, it will form another organic compound which are made up of double bonds. So an alkene will be our product. So we have propan, or 1-propanol, producing us propene. This could be used as a laboratory method to prepare alkenes in the lab. Another reaction of alkanols we're going to look at is reacting with oxidizing agents, that is acidified potassium permanganate or potassium dichromate. Alcohols or alkanols are oxidized by strong oxidizing agents to produce either acids or alkanals or alkanols, depending on what type of alcohol it is, whether it's a primary alcohol or secondary alcohol or tertiary alcohol. Okay? So looking at the various classes of alcohols, primary alcohols can be oxidized, secondary alcohols can be oxidized, but tertiary alcohols cannot be oxidized. Why? Because there is no hydrogen to be oxidized in tertiary alcohol. So therefore, oxidation of alcohols will be only primary alcohols and secondary alcohols. Tertiary alcohols cannot be oxidized by these oxidizing agents. So let's take an example of a primary alcohol. This is a primary alcohol. When it reacts with one of these oxidizing agents, in the presence of acid and heat, okay, if you have excess of what? Potassium permanganate, it will oxidize this alcohol into an acid, organic acid. So all the hydrogens will be oxidized. So we'll end up having a compound that looks like that, which is an alkanoic acid. Okay? But if it is limited potassium permanganate, an aldehyde will be formed first. So this reaction can be a two-step reaction. Okay? That is, first we'll produce an alkanal, which will look like that. Okay? And this alkanal will be further oxidized by the oxidizing agent to produce the acid. So the alkanoic acid will be your final product. So if you are taking two-step reactions, the first step will produce that, and then the final step will produce the acid. Okay? So primary alcohols are oxidized into alkanoic acids. And secondary alcohols can also be oxidized by oxidizing agents like the strong oxidizing agents in the presence of acid and heat. Okay. So secondary alcohols are oxidized into compounds like these are alkanones, or we call them ketones. So secondary alcohols are oxidized into ketones or alkanones. So the hydrogen here is oxidized. But if you look at a tertiary alcohol, the tertiary alcohol has no hydrogen to be oxidized. So therefore, when it reacts with oxidizing agents, no product will be formed. there is no hydrogen to be oxidized here. This reaction therefore would not be possible. So if you have this reaction, you'll have no reaction or no product form. And finally, we are going to look at the reaction of alkanols with iodine in the presence of a base. And this reaction is called iodoform reaction. This reaction is called iodoform reaction. And it has a general formula, which is so reactions with iodine in the presence of sodium hydroxide, ethanol and secondary alcohols contain a structural unit that looks like that and are therefore oxidized to pale yellow triiodomethane on warming with iodine in the presence of sodium hydroxide solution. Let's take an example. For example, if you have this molecule as our example, reacting with iodine in the presence of aqueous sodium hydroxide and heat, this will produce triiodomethane, CH3, CHI3. This is your triiodomethane, and the final product will be okay. So as we can see, this is a secondary alcohol and is reacting with iodine in the presence of what? Sodium hydroxide solution and heat to produce a triiodomethane, and then an ester salt is another product. Okay. Like we mentioned earlier, ethanol and secondary alcohols or alcohols contain a structural unit that looks like that and are therefore oxidized to pale yellow triiodomethane. So this is our pale yellow triiodomethane. This could be used as a chemical test to test for the presence of secondary alcohols and ethanol. So that brings us to the end of this lesson. Until we meet next time, bye for now.
Hello viewers, these are key messages from the Ministry of Basic and Secondary Education on the coronavirus. Dear parents, keep children at home at all times. Avoid sending children to shops and markets. Do not engage children in petty trading on the streets and garages. Allow children to play within the confines of the home. Limit visitors into your homes. Adhere to COVID-19 health precautions and guidelines. Schools are closed, but learning continues. Dear teachers, you are encouraged to desist from all forms of group activities involving students. All school premises should remain closed and not to be used for any other purpose. Thank you.
In communication, connectivity is everything. We ensure that the links never sleep. Quantities and qualities, all in our data service, providing efficient, reliable voice and data service. We believe if you're not up to speed, then you're going backwards. Communications have to flow as fast as the speed of light. Whatever business you're in, having someone who understands your needs is critical. That is why we just don't offer you technology, we offer you solutions. Enjoy Gamcel's internet broadband anytime, anywhere. Your national operator, Gamcel, Yaibaram.
Agada
Mbijan raganya
Albaka
mbaka important
yo nga transfer la sto
ya transfer
ha code nyinji
okay for some nsila ID soto
sa soto sorry Agada
Mbijan bro
Albaka
mbaka
bara alla service o tariaka
bare
mo ki janna nun kunu bara tariaka
jannom yona forest de bureau Gambia tonkon na lo mbali ya bere birim koyna fo kato
bari si kodo kino kato nim fo bolon blabe
56 branches mola soto Gambia jam
ha
Gambia kono ani Gambia bantala bankol nko kodo kiya bele kodo sifa fo falindiro fo nyaadi lafta même na kodi to poto nin kodi maraw jannam number 1 di nyonta andum fana nata anoda enterprise sotale wolam nyindi ko domorol fana kol fana be firale de dadi man domorol dil fana beteat Gambia dawda yalo ngam fa kendol sotale je
wo moyo diat
apelenta
baraka ba ya lafta nyelen kendol e bina
yalo bukani la ko la baraka ba
yalo ndel ciosano lo
baraka
When we touch down, better broke down.
Gamtel G-Fiber, now you can enjoy super fast internet in gigabytes. G-Fiber is affordable, stable, secured, and accessible to homes, businesses, and enterprises. With Gamtel G-Fiber, the future is speed. Gamtel, creating a brighter future in communication.
That's how she became mine and see that.
yara ñilla domoro ka diaten
boy jannon CK's restaurant
e say nakko be ni na dimbal nimbe domoro kala janno
domoro seneyata adiyata topotoro fanan kendema bije luntan during tamala abeka domoro ki janni adi manda wala de te ka we bijele anim fanan ka fadi jang ikono e fa e ka fa minne ko pastry anim bakery iko fanan be kalele badde lomba conference lomba workshop lomba ye fo fendin lon dunia kono domoro betama nyillom international otoda number 1
amanke ba domolo jandama
e sa domo jang is atariya
wo mu kubandi
sa nakko sa futandin
e oto sa nakko be mu CK's restaurant
ndafa nan janna mu yat ni manje dorom bijam
aban
CK's restaurant, known for best quality food and customer satisfaction.